Hello everyone. Today I'm going to give you a video tutorial all about special first order differential equation. Now, there are many types of differential equations, and one of these is the Bernoulli differential equation, and next is the Riccati differential equation, and Clairaut differential equations, and many other more. Now, I'm going to give you a video tutorial all about the Riccati equation. A Riccati equation has this following form: dy over dx is equal to a function of p in terms of x variables y squared plus q, a function of q with x variables, times y plus a function of r with x variables. Now, this is the form or the standard form of the Riccati equation. So, for us to solve this, for us to solve a differential equation involving a Riccati equation, we might needing this substitution. We need this substitution. Y is equal to, let us say, a function of u in terms of x variables plus 1 over z. Now, you are maybe asking why we are using this thing. Now, of course, a function of u, that means there is an equation that has a function, what I mean is a function that has x variables in it. So, and we add 1 over z since our power here is just equal to 2. Now, take note, this idea comes from, of course, from the Bernoulli differential equation. Now, in the Bernoulli differential equation, we need the substitution y is equal to y minus n, 1 minus n is equal to z. That's right. So that means our z here, we just add a function of u in terms of x variables. Now our z is equal to 1. Z is equal to, if we make this a function of u is equal to 0, so that means our z is just equal to 1 over y. That means we have a 2, our n is 2, so that means y is equal to negative 1. So that means our z is equal to 1 over y. So that's it. So in Riccati equation, what we need is this substitution. So, simplifying the equations, then we might get a differential equation that can be solved easily by maybe a separable differential equation or a linear differential equation. So let's take an example. This example comes, of course, from the book of Ray Wiley, that was Advanced Engineering Mathematics. That book was I always mentioning on the last video tutorials, because that book, our guide, that was the book we are using in our class. So for example, we have this equation: y prime is equal to quantity x plus y times x plus y minus 2. And of course, let us say our condition, our u, a function of u in terms of x, is equal to y minus x. And this problem comes from that book on page 38, number 20. Just search for that book and you will find this equation. So just a recall, when we have a Riccati equation, all we need to have is this substitution: y is equal to, which is this one. In this problem, we use this one. You just have to substitute this in here, plus 1 over z. Why is it 1 over z? It's because of this principle. So let's solve the problem. I'm gonna write the problem. Y prime. Last time we take note that y prime is just equal to dy over dx, right? So I'm just writing the equation x plus y minus 2, and our condition, our u of x is just equal to 1 minus x. So our substitution, or our y, so we let y is equal to 1 minus x plus 1 over z. Okay, so from this equation we need to make it in the standard form. As you can observe, it is not yet in the standard form, so we'll try it to make in this form. How we use this? Okay, so as you can recall from the Math 17, if we let this thing into u, let us say to solve or to make the equation into Riccati equation. Okay, Riccati equation. So let u maybe use v, because we might confuse. We use u variable here and we're still using u, so to avoid ambiguity we just use v for our substitution here. So our v is equal to x plus y, so that means dy over dx is equal to u times u plus u minus 2. So it's just equal to u squared minus 2u. So going back to the equation, so it's just such that what happened to the equation is just like this. Dy over dx is equal to, our u is just x plus y squared u squared minus 3u minus 2 times x plus y. Okay, so this is x squared plus 2xy plus y squared minus 2x plus 2y minus 2y. This is minus 2y. Okay, so we are trying, what we're gonna do, we are trying to make this in this equation. So let's put this in an order like this. dy over dx, it is this one, and y squared. This term only contains y squared, so just write it y squared, and then y variables. This is 2xy, I'm so sorry, and then plus y times 2x minus 2 plus x squared minus 2x. So as you can observe, our p of x in here just equal to 1, right? And then our q of x is just equal to 2x minus 2, and our function of r is just equal to x squared minus 2x. See? So this equation is our Riccati equation. So we will use this substitution. Okay, so we let this substitution, and then we'll solve for this equation. This is now our equation. Okay, this is now our equation. So we'll substitute it in here. Okay, solution. See the solution. Okay, so dy over dx, and this is our y. So if we're gonna derive it, in terms of dx, so what happened is derivative of 1 in terms of x, that is 0, minus derivative of x, that is 1, plus derivative of 1 over z, that is negative 1 over z squared dz over dx. Okay. This is 1, this is 1, and then we substitute y squared, or y squared is this. Substitute 1 minus x plus 1 over z squared plus 1 minus x plus 1 over z times 2x minus 2 plus x squared minus 2x. So we transpose 1 into here, and then we have to simplify these equations right here. So I think we let this into one term for us to have the power of 2 of this thing right here. Okay, so it's transpose 1 over there, so we have this equation 1 over z squared dz over dx is equal to 1 minus x squared from this thing over here plus 2 times 1 minus x times 1 over z, that is z, 1 over z times 1 over z, plus 1 over z squared. Okay, and then plus, by distribution property, 1 times 2x minus 2, that is 2x minus 2, minus this minus x times this 2x minus 2, type in s, negative x times 2x, that means negative 2x to the power of 2 plus 2x. Okay, and then with z plus 1 over z times this one, we have 2x over z minus 2 over z plus x squared minus 2x, which is this one. So we have to, still we have to make this into a single term like this, that this thing is just 1 minus 2x plus x squared. We forgot 1 here, since we transpose 1 over here, so that means we have to plus 1 over here. Okay, plus 2 times 1 over z, that means 1 over z, so that means 2 over z, and then minus 2x over z plus 1 over z squared plus 2x minus 2 minus 2x squared plus 2x plus 2x minus z minus 2 over z plus x squared minus 2x plus 1. So we could 1 plus 1 is 2 minus 2, that means these things will cancel out. Okay, negative 2x and we have positive 2x, this thing will cancel out. X squared plus x squared, that means 2x squared minus negative 2x, that means minus 2x squared, cancel out like this. 2 over z, and we have negative 2 over z, cancel out. Negative 2x over z and positive 2x over z, cancel out. And then 2x and negative 2x. Okay, so what remains is 1 over z squared. Wow, amazing. This thing is amazing. And of course we have 1 over z squared dz over dx. Wow, what a wonderful thing. We start from a very difficult large equation and we end up with this equation. Wow, that is amazing. So since this is not in its standard form, let's multiply it by negative z squared. So we have dz over dx is equal to negative 1. Amazing! Now from this equation, what can you observe? Of course, we can solve it by linear differential equation and by separable differential equation. See? It's amazing. From this equation we substitute it with this and we end up with this thing over here. Wow. Riccati equation is a lovely equation. I'm having an interest for this. This is so interesting. Now let's continue. Our last equation. Okay. What we have so I'm gonna choose which technique of solving this equation. Maybe this linear or this separable. What do you think? Maybe separable. So let's use separable. After I solve the equation by separable, I think it's your time to solve it by linear. Okay? So that was your assignment. I'm really a good teacher, you know. So our last equation is dz over dx is equal to negative 1. Okay? And we're gonna solve it by separable differential equation. Okay. So by separable differential equation, just multiply it. Here we have dz equal to negative dx, and we integrate both sides. That means we have z is equal to negative x plus constant c. But remember our y is equal to 1 minus x plus 1 over z. Now to solve for z, we have y minus 1 plus x, but this is over 1, right? Okay, I think you got it. So we will substitute z to this equation. Then we will have that z is equal to 1 over, that means x plus y minus 1 to make it a beautiful stain, and we have negative x plus c. So I think this could be a very good answer already, but I think we have to find a solution that is in this form, a function of y in terms of x variables. So something like this. So we will have to multiply this by the whole thing with this 1, x plus y minus 1. So this remains 1 negative x to the power of 2 minus xy minus, positive x plus cx plus cy minus c. Okay, so all terms that has y variable, I think we have to transpose it here on the left side, and this one will transpose it on the right side. So we have our xy, negative xy, it will become positive xy minus cy is equal to negative x squared plus x plus cx minus c minus 1. And then this is y is equal to x minus c is equal to negative x squared plus x plus cx minus c minus 1. And then our y is just equal to negative x squared plus x plus c of x minus c minus 1 over x minus c. And this is our final answer. Okay? So, this is our final answer. Thank you for listening, and get blessed to your study and have fun solving engineering mathematics. Thank you.